So here it is Arka sir. So I have come with another fresh and new episode on topic current electricity for JEE and NEET students. Okay, JEE and NEET special. Okay. So as we have started, I have uploaded two episodes previously. So I have solved some MCQ type of questions. Clear? So today we will also do the MCQ. Okay. So for your practice, as much as you will practice, I think your concept will be clear and you will come to know how to solve that, okay, in the examination hall. Clear? Because within a specific time period you have to complete your examination also. So a huge practice is required. So if you can continue to follow my channel, the NEET special episodes, all the NEET special episodes, I hope it will be very much beneficial for you. Okay. So without further delay, let us now start for today's episode. Clear? So first question is a theoretical question, not numeric sum. Today's first question: wire bound resistors are made by. Okay, wire bound resistors are made by. Students, remember one thing: wire bound resistors are made by some metals. Okay, or the component which the resistors, the resistivity will be insensitive of temperature. Okay, as much as possible. Clear? Insensitive of temperature as much as possible. That means if the temperature also varies, because when the current will flow through a resistor, the heat will be generated, and if the resistivity will change, okay, then what will happen? Then also the resistance will also change. Clear? So basically it will be bound with some metals which in which the resistivity will be insensitive with temperature. Okay. So these are the materials: manganese, okay, constantan and nichrome. These three are the materials, okay, for which the resistance sensitivity, the resistivity, okay, the resistivity will be insensitive, okay, for the temperature. Clear? So that's why the number D will be the correct. So which are the three the wire bound resistors are made by what? Manganese, constantan and nichrome. Manganese, okay, constantan and nichrome. Clear? So basically the value of resistivity will be what? The fraction of the value of resistivity will be what? Fraction of ohms to few hundreds of ohms. Okay. So this is the value of the resistivity lies. Clear? So this will be the correct option: manganese, constantan and nichrome. Clear? So now the next question, question number 2 for today's episode: range of resistivity for metal. The range of resistivity for metal. The range of resistivity for metal will be, okay, that you have to memorize: 10 to the power minus 6 to 10 to the power minus 8 to 10 to the power minus 6 ohm meter. Clear? The range of resistivity of the metal will be what? 10 to the minus 8 to 10 to the minus 6 ohm meter. Clear? So option third will be correct. Here 4 options are given. So if you know the value, then whatever the options are given, you have to click on the right option. Clear? So here option C is correct: 10 to the minus 8 to 10 to the minus 6 ohm meter. Clear? So now I hope you have understood. The wire bound resistors are made by what? Manganese, constantan and nichrome, as their resistivity is insensitive with temperature. Clear? That's why they are preferred. And the range of the resistivity of the metal is 10 to the minus 8 to 10 to the minus 6 ohm meter. Clear? So now let us move to the question number 3. So students, now here we will move to question number 3 and 4. This is also the theory based questions. Clear? So question number 3: two copper wire of length L and 2L have radius R and 2R respectively. The ratio of their specific resistance. Okay. So the length of the two copper wires are given. The length of the two copper wires are given. One is L, another is suppose 2L. Clear? It is given. And their resistance is R and twice R. Clear? So the ratio of the specific resistance. So remember one thing. This is basically questions to make you confused in the examination. Clear? So the specific resistance does not depend upon the clear length or dimensions of the conductor. It does not depend upon the dimension of the conductor, but it depends upon the materials of the conductor. Clear? Here the materials is same. That means what? It is copper wire. Clear? So their specific resistivity or specific resistance will be same. Okay, whatever is their length, clear? So their what specific resistance will be same. So it will be what 1:1. Okay. So the specific resistance of any conductor does not depend upon their dimensions, but it will depend on the materials of the conductor. So here both the wire are made of copper. So that's why the specific resistance will be 1:1. Clear? The ratio of the specific resistance will be for the both the wire will be 1:1, as both the wire are made of copper. So hope you have understood this. Now move to question number 4. The resistivity of alloy manganese is just we solve these questions. Question number 2 you can understand. Clear? That means their resistivity will be independent of temperature. Clear? So that means if the temperature varies, then their resistivity will not change much, almost independent of temperature. So this option A will be correct. Okay, nearly independent of temperature. Option B was increases rapidly with increase in temperature, decreases with increase in temperature, increases with decrease in temperature. So the option A will be correct. Okay, that means what nearly independent of temperature. Clear? So these two questions, okay, very easy. Clear? So hope you have understood this. Clear? Now students, let us move to question number 5. Okay students, now it is question number 5. What is question number 5? The temperature dependence of the resistivity of a semiconductor. That means germanium, silicon. Clear? So these are the semiconductor. There are p-type, n-type semiconductor in modern physics. Okay, I will discuss on that. Okay, so semiconductor is given by, so 4 actually graphical representations or graphs are given. Clear? Now the thing is that what we know in case of the conductor, if we increase the temperature, then the resistivity will also increase. That means in case of the true conductor, if we increase the temperature, then what? Then also the resistivity will increase. The temperature increases, resistivity also increased. Clear? So the increase of temperature, resistivity is increasing. So this graph is for the true conductor. Clear? But in case of the semiconductor, what we know? In case of the semiconductor, there is a small gap between the valence band and the conduction band. So if we increase the temperature, then some electrons from the valence band will come, okay, come to the conduction band, and these electrons are free electrons, and they can conduct the current. Clear? That means what? If we give the temperature, then number of free electrons will increase, and that's why they can conduct current. That means the resistivity will decrease. Clear? As what they can conduct current, that means what their resistivity will decrease, because resistance will oppose the current to flow. Okay, so that's why. Okay, so this C, if you see the graph of C, it is what? With temperature the resistivity decreasing. That means this is for the graphical representation for semiconductor. Okay, semiconductor. So so if it is here given the which is correct for the semiconductor, okay, between the graph of the temperature as well as the resistivity, so option C will be correct. As the temperature increases, the resistivity will decrease. Okay, why resistivity will decrease? Because the number of free electrons will increase. The more amount of electrons from the valence band to conduction band, it will move. Clear? But in case of the first graph, for the pure conductor, if we increase the temperature, basically the resistivity of the conductor will decrease. Clear? Resistivity of the conductor will increase. Okay, but in case of the semiconductor, okay, this is what? If the temperature increases, resistivity will decrease. So here for the semiconductor, option C will be correct. If the same question will come for the conductor, then this option will be correct. Clear? But as it is semiconductor, so these options will be correct. Option C. Clear? So hope you have understood this. Now let us move to the question number 6. Okay students, so now 2 theoretical questions, you have to memorize the value. Clear? So very often this type of question comes in the NEET or joint. What is the order of magnitude of the resistance of a dry human body? Clear? So the dry human body, so it will be what? 10 kilo ohms. Clear? So the answer will be option B. Clear? So 10 kilo ohms. So what is the magnitude of resistance of the dry human body, okay, body of ours, okay, in dry condition it will be 10 kilo ohms, clear, and obviously in the wet condition the resistance will decrease. Now next question, a resistor is marked with the rings colored brown, black and greens, clear, the color codings are there, okay. So the resistance in ohm is, okay, so what will be the, if the color code is brown, black and green, then the resistance will be 1 into 10 to the power 6 plus minus 5%, that means it can increase by 5% or decrease by 5%, clear. So the resistance will be what, 1 into 10 to the power 6 plus minus 5%. So the answer for this question will be answer D, okay. So this question, the answer, the resistance of the dry human body will be 10 kilo ohm, clear, and the color code, if the resistor is marked with the rings colored brown, black and green, then their resistance will be 1 into 10 to the power 6 plus minus 5%, clear. So hope you have understood this, okay. So now let us move to question number 8, okay. So let us now move to question number 8. Okay students, so now it is a numeric problem, two cells of epsilon 1 and epsilon 2 or whatever is given, clear, it may be given U1, U2 or XY, whatever, okay, connected in opposite to each other as shown in the figure, okay. So you see the direction is also given, direction of the current is also given, that means what, it is from plus direction to minus direction, clear, and here it is minus to plus, clear. Now the thing is that means it is in forward bias and it is in reverse bias, okay. Both are connected in opposite direction, that means both negative terminals are what, in the same side, clear, and this will be in opposite side, positive terminal, okay. So it the cell epsilon 1, okay, this have what, the internal resistance is EMF is 5 and internal resistance is 7 ohm, okay, internal resistance is 7 ohms, clear, and the EMF is 9 volt, EMF is 9 volt and it is 7 ohm, and the potential, okay, epsilon 2 it will be what, 7 volt and internal resistance is what, 7 ohms, clear, and internal resistance is, sorry, it is 3 ohms, clear, 3 ohms and it is 7 ohm, clear. Now we have to find out the potential between A and B, okay, the 4 options are given, 8.4, 5.6, 7.8, 6.6, clear. Now they are connected in opposition, clear. So that means what, the current I will be what, change of their EMF divided by what, they are connected in series, that means the internal resistance R1 plus R2, clear, the equivalent resistance, okay. So what will be the change of voltage, change of voltage will be delta E, that means it is 9 minus 7, so 9 minus 7, so 3 plus 7 is equal to what, 2 by 10 is equal to 0.2 ampere, okay, 0.2 ampere. Now the voltage across this, across epsilon 1, clear, across this what, 9 minus the loss volt, clear, due to the internal resistance, so 3 into 2, that means 9 minus 0.6 is equal to 8.4 volt, clear, and the in case of the potential difference across epsilon 2, okay, VAB, that we have to find out, VAB, clear, that means the potential difference across this, okay. So 7 plus, why, because the current is passing here, but actually the voltage is high over here, okay, that means what, it will be plus, okay, means instead of minus, so it will be the minus sign, clear. So that's why it will be clear, plus sign, clear. So 7 plus 0.2 into 0.2 means what, current flowing I, okay, into the internal resistance of this is 7 ohm, clear. So 7 plus 1.4 is equal to 8.4 volt, clear. So the option A, so answer will be what, 8.4 volt, okay. So that will be the answer, because this voltage is more, that's why the current will flow in this direction, okay. So the current from the positive terminal to negative terminal, okay, to this direction, and here it is what, from positive to here the current is flowing what, inside the battery from positive to negative, that's why it is here the plus sign, clear, because actually the current inside the battery will flow from this terminal, clear, and but outside the battery it will positive to negative, but outside terminal it is flowing in this direction, but inside it will be flow in this direction, clear. So that's why, okay, what, it will be plus sign. So the epsilon 1 is equal to 9 minus 0.2 into 3, that means this, okay, and epsilon 2, that means what, the voltage across the B, and that is 8.4 volt. So option A will be the right answer. Okay, so hope you have understood this, clear, and if you can pause the video and can copy the sum. Okay, now let us move to the sum number or the question number 9. So students, now let us move to question number 9. With increase in temperature, the conductivity of metal increases and semiconductor decreases, semiconductor increases and metal decreases. In both metal and semiconductor increases, okay, in both metal and semiconductor decreases. Okay, always remember that actually, okay, temperature coefficient of semiconductor is negative, and temperature coefficient of metals or conductor is positive. Clear? That means what? If temperature increases, then what will happen? In case of the semiconductor, the conductivity decreases. Clear? So the if and what will happen in case of the metal? If temperature increases, then conductivity will also what? Increase. Clear? So the metal increases, okay, and the conductivity, okay. So that means what? The in increase in temperature, the conductivity of semiconductor increases. Clear? Because what? The resistance in case of the semiconductor, if we increase the temperature, then what will happen? The resistance will also decrease. Clear? As the resistance will decrease, that means what? The increase in what? Increase in conductivity. Clear? Conductivity is opposite, okay, reciprocal to the resistivity. Clear? So if the temperature increases, okay, then the resistivity will decrease, and as a result the conductivity will increase. But in case of the metal, if the temperature increases, then what will happen? Resistivity will increase and conductivity will decrease. Okay, so that means the option B will be the correct. So the answer will be option B. Clear? Answer will be option B. Okay, so semiconductor increases, okay, the conductivity of semiconductor will increase and the metal will decrease. Why the conductivity of semiconductor increase? Because when the temperature increase, then the resistivity of the semiconductor will decrease. Clear? More amount of free electrons will available, and that will conduct the current through it. That means the conductivity will also increase. Clear? And when the temperature decreases, increases, then what will happen? In case of the metal, the resistivity will increase. That means what will happen? It will oppose the current to flow through it. Resistivity will increase. That means conductivity will decrease. Okay. So the semiconductor increases and the metal it will decreases the conductivity. Clear? So hope you have understood some of the question number 9. Now let us move to question number 10. Okay students, so now here it is the question number 10. Clear? It is a numeric problem. The resistance of a heating element is 99 ohm at room temperature. So basically the room temperature will take as 27 degree centigrade. Clear? The normal room temperature. Here it is given. Clear? What is the temperature of the element if the resistance is found to be 116 ohm? Clear? That means temperature increases, and at room temperature the resistance was 99, and what will be the temperature, okay, of the element when the resistance is found to be 116 degree, and the temperature coefficient, that means alpha, is given. Temperature coefficient of the materials is given. Clear? Now the thing is that 4 options are given. 4 option 999.9 degree centigrade, 1005.3 degree centigrade, 2020.2 degree centigrade, 1037.1 degree centigrade. Clear? And the coefficient, that means alpha, okay, it is denoted as alpha. It is 1.7 × 10⁻⁴ degree per coulomb. Clear? It is given. Now what? R0 means what? The initial resistance, okay, at room temperature. Clear? The initial resistance at room temperature is 99 ohm. It is given in the question. Clear? Now T0 means what? The room temperature. Room temperature is what? 27 degree centigrade. Clear? So RT RT means what? The final resistance at T degree temperature. That means the final temperature. RT is what? What is given? 116 ohm. Clear? And alpha, what is the value of alpha is given? 1.72 10 to the minus 4 degree per coulomb. Clear? That is the temperature coefficient of resistor. Okay. Temperature coefficient of resistance alpha is equal to 1.72 10 to the minus 4 degree per coulomb. Clear? So now what is the formula? What is the formula we know? RT is equal to RT. What is the formula? RT is equal to what? R0 into 1 plus alpha into T minus T0. That means change in temperature. Clear? Or increase in temperature. Clear? So RT is the final resistance. R0 was the initial resistance. Alpha is the temperature coefficient of resistance. And T minus T0 is the increase in temperature. Clear? So that formula we have used over here. What RT is equal to R0 into 1 plus alpha into T minus T0. Okay. So now R0 we are taking here down. So RT minus R0 is equal to what is there? And this 1 also we are taking here. So it is plus, so it will be minus. So RT by R0 minus 1. Clear? Is equal to alpha into what is left? This part will be left. So it will be what? Alpha into T minus T0. Clear? So RT minus R0, we know the value. What is the value of RT? 116. And R0, what is the value of R0? 99. So 100 by 16 divided by 99 minus 1. Clear? Is equal to alpha into T minus T0. Clear? Now T minus T0 is equal to what will be happen? 1 by alpha into what? 116 by 99 minus 1. So 99 will be the LCM. So 116 minus 99. 1 by alpha into 116 minus 99 by 99. Very simple. Clear? Then 1 by alpha into what? Now 160 minus 99 means 17 by 99. Clear? Now what is the value of alpha? 1.7 to 10 to the power minus 4. So we are writing 1.1 by alpha means 1.7 to 10 to the power minus 4 into 17 by 90. Clear? So if these things will be there, then this will be 10 will be here. Clear? So this and this will be cutted. So what? 10 will be there. So 10 to the power minus 4 into 10 means what? 10 to the power 5 divided by 99. 10 by 10 to the power minus 4. That means 10 to the power 5. Okay, minus 4 means it will be plus 4 and 1 means what? 5. So 10 to the power 5 divided by 99. So if we do this, then it will coming. It will come what? 1010.10 degree centigrade. Now it is what? It is nothing but T minus T0. It is what? T minus T0. So what will be the T? T means what? T plus this plus T0. Clear? This plus T0. So T0 will be that side plus. So this plus T0. Okay. So what is the value of this? 1010.10 into T0 means what? The room temperature. What is the value of room temperature? 27. So it is we are adding 27 over here. Okay. The value of T0 we are putting. So it will be what? 1037. That means 1037.1 degree centigrade. 1037.1 degree centigrade. So that means which option is correct? That means option D. So the answer will be option D. Clear? Option D will be correct. 1037.1. Okay. So student, I am explaining it once again. Okay. The one metal is given. Okay. The resistance of the room temperature heating is given. Now as the heat current is flow through it, then what will happen? The temperature will rise and also the resistance will increase. Clear? So resistance will increase and resistance is found to be 116 ohm. So we have to find out the temperature. At which temperature the resistance of the materials will be 116 ohm. Clear? And also the temperature coefficient of resistance is given. Okay, alpha is given. Clear? So what we know? R0 is equal to 99 initial resistance. T0 means in room temperature 27, RT means final resistance 116, and alpha is given 1.7 10 to the minus 4 degree per coulomb. Clear? So what is the formula? RT is equal to R0 into 1 plus alpha into T1 minus T0. Clear? So RT minus R0, RT by R0 minus 1 is equal to alpha into T minus T0. Therefore what is the value of RT? 116 by 99 minus 1 is equal to alpha into T minus T0. Now alpha we are moving that side. So T minus T0 is equal to 1 by alpha into this part will be the LCM, 99 will be the LCM. So 116 minus 99, 160 minus 99 means what? 17 by 99 into 1 by alpha. The value of alpha is what given? 1.7 10 to the minus 4. Clear? So it is coming 10 to the 5 by 99. So after calculation, what is coming? 1010.10 degree centigrade. So T is equal to 1010.10 plus T0. What is the value of T0? Nothing but 27. Clear? So it will be 1037.1 degree centigrade. Clear? So this will be your sum. Easy? Clear? Only you have to understand how to do the sum and what is given. Clear? So hope you have understood this. So here the answer will be option number D, 1037.1 degree centigrade. Clear? So now let us move to the question number 11. Students, let us now move to, that is another numeric sum, okay, a numeric problem, the question number 11. The resistance of the wire in a platinum resistance thermometer at ice point means 0 degree temperature, clear, 5 ohm, okay, and at steam point means what? Ice point means 0 degree, clear, and steam centigrade, and steam point means what? 100 degree centigrade, clear. The point is what? 5.25 ohm. When the temperature is when the thermometer is inserted in an unknown hot bath, that okay, its resistance is found to be, that means resistance will increase, okay, 5.5, clear. So at 0 degree temperature, ultimate story is at 0 degree temperature the resistance is 5 ohm, at 100 degree temperature the resistance is 5.25 ohm, clear. And when the resistance is 5.5 ohm, at that time we have to find out the temperature of the hot bath, clear. After inserted, when the resistance of the thermometer is found 5.5 ohm, clear, then we have to find out the temperature of the hot bath, clear. The 4 options are given: 100 degree, 200 degree, 300 degree, 350 degree, clear. Now what is R0? Means temperature at 0 degree temperature, okay, temperature at 0 degree, okay, R0 means what? 5 ohm. So R0 means what? 5 ohm. Temperature at it is what? 0 degree centigrade temperature, clear, 5 ohm. It is what? A steam point means at 100 degree, clear. The temperature, the resistance is what? It is 100 degree centigrade, 5.25 ohm, clear. RT means the final temperature, clear, that we have to find out, okay. At that temperature, okay, the resistance, okay, is 5.5. T is the final temperature, so RT, that resistance at that final temperature is 5.5 ohm. Now what is the formula? RT is equal to R0 into 1 plus alpha T, clear, very easy. Now we don't know the value of alpha over here, clear. Now what is RT? So first what we can write? R100 is equal to 100 means, suppose first we will consider the 0 and 100, clear. So it will be R100 is equal to R0 into 1 plus, what is the value of T means final temperature 100 degree, clear. So that means what? The temperature difference is what? 0 minus 100 means 100 degree. So that means R100 is equal to R0 into 1 plus 100 into alpha, clear. Now from here what is alpha, clear. So from here what is alpha? Alpha is equal to R100 minus R0 divided by R0 into 100, clear, okay. So that is the value of alpha. From this equation we can find out the value of alpha. It is equation number 1. Now let the final temperature is T, clear. So now RT is equal to what? Now the T with the 0 degree, clear. So it was 100 degree with the 0 degree and the 0 degree. Now it is now T with the 0 degree. So RT is equal to R0 into 1 plus alpha T, same formula, clear. Now here alpha is equal to what? From this equation it will be RT minus R0 divided by R0 into 100, clear. 100 means here T, clear. Here RT minus R0 divided by R0 into T. It is equation number 2. So in both the cases we can compare equation number and equation number 2, clear. That means what? RT minus R0 divided by R0 into T is equal to R100 minus R0 divided by R0 into 100, clear. So that we are writing R100 minus R0 divided by, that means this one, R0 into 100 is equal to RT minus R0 divided by R0 into T. Now from this what we are calculating? T is equal to what is coming? RT minus R0 divided by R100 minus R0 into 100, clear. Now what is the value of RT? Value of RT is what? Value of RT is 5.5. And R0, what is the value of R0? R0 means 5, clear. R100 at a resistance 100 degree temperature 5.25 minus R0, that resistance at 0 degree or ice point is 5 into 100. So it's very simple calculation now. 5.5 minus 5 means 0.5 and 5.25 minus 5 means 0.25 into 100. So it will be 200 degree centigrade. So the option B, answer will be what? Option B. So answer will be option B will be the correct answer. So option B will be the correct answer, clear. So I am explaining it once again, okay. So 3 temperatures are given, 0, 100 and T, clear. Now we have to find out the temperature T, okay. So at 0 degree, okay, the resistance is 5 ohm. At 100 degree the resistance is 5.25 ohm, and RT means at T degree the resistance is 5.5 ohm. you see as the temperature increases, resistance is also increases. That means it is a metal. Clear? Now RT is equal to R0 into 1 plus alpha T. Now RT means first we will consider these two. So RT means here what it is R100 is equal to R0 into 1 plus temperature difference means 100 into alpha. Clear? So now alpha is equal to R100 minus R0 divided by R0 into 100. Now let the temperature is T degree. So RT is equal to same R0 into 1 plus alpha T. So alpha is equal to RT minus R0 by R0 into T. Clear? So temperature difference what? 0 minus T means T. Clear? So T minus 0 means T. Clear? So comparing 1 and 2. So this into this is equal to D. So R100 minus R0 divided by R0 into 100 is equal to RT minus R0 divided by R0 into T. So from here T will be RT minus R0 divided by R0 into R100 minus R0 into 100. So what is the value of RT? 5.5, R0 5, R100 5.25, R0 5 into 100. So 200 degrees centigrade. It's very easy. Okay, but you have to only understand how to do this sum. Clear? So hope you have understood sum number or the question number 11. The answer will be option B. So I have written the answer also. So students, hope you have understood this sum. So this type of sums actually used to come in the joint and NEET examination. So if you practice, then obviously it will help you a lot in the examination, believe me students. Clear? Now let us move to the question number 12. So now let us move to the question number 12. Clear? Now the resistance, this is a numeric problem. Clear? The resistance of the wire in a heater at room temperature is 65 ohm. Room temperature means what we will assume 27 degrees centigrade. Clear? If the room temperature is not given also, then also we have to assume as 27 degrees centigrade. When the heater is connected to a 220 volt supply, the current settles after a few seconds. That means the flow of current is 2.8 ampere. Okay, and the voltage of the supply is 220 volt. Okay, what is the steady temperature of the wire? That means the temperature of the wire we have to find out. Clear? And the alpha, that means temperature coefficient of resistance is given 1.70 into 10 to the minus 4 degree per coulomb. Okay, so this type of sums little bit different we have done earlier. Okay, in this episode only, and now this is another sum. Okay, so this type of sums, this variety of sums are very important for the NEET and joint examination. So the options, 4 options are given: 955 degrees centigrade, okay, 1055 degrees centigrade, 1155 degrees centigrade, and 1258 degrees centigrade. Now here, what is the initial temperature? T1. Clear? The room temperature T1 is what? 27 degree centigrade. Clear? R1, that means resistance at room temperature. It is given what? 65 ohms. Clear? So that we are writing R1 is equal to 65 ohms. Okay. R2 means what? What we know? V is equal to, from the Ohm's law, V is equal to what? I into R. Clear? So R is equal to what? V by I, voltage divided by current. So R2 is equal to voltage divided by current. Okay, so what is the voltage? 220 volt. 220 volt is the voltage of the main, and current is what? 2.8 ampere. 2.8 ampere is given in the question. Clear? So that means what? 78.6 ohms. Clear? So the final resistance, okay, after rising the temperature is what? 78.6 ohms. Now let the final the final temperature is suppose the T2. Clear? So what is the formula? R2 is equal to R1 into R2 is equal to R1 into 1 plus alpha into T2 minus T1, the difference of temperature. Okay. So from here what we know, R2 by R1, R2 minus R1 divided by R1, T2 minus T1 is equal to what? This will go there. So it will be what? R2 minus R1 by R1 into 1 by alpha. Clear? So what is the value of R2? The value of R2 is that we have found out 78.6. 78.6 minus R1. What is the value of R1? The value of R1 is given 65. Clear? Divide by R1 means 65 into alpha. Value of alpha is given temperature coefficient of resistance 1.70 into 10 to the power minus 4. Clear? So we are putting all the values over here. Clear? And now only the calculation. Okay. So from this, okay, what is coming? Then T2 minus T1, that means what? This one, T2 minus T1 is equal to, okay, after calculation this is coming, okay, 1, 2, 3, 1. it will be 1, 2, 3, 1. Clear? So T2 is equal to what? 1, 2, 3, 1 plus T1. T1 is nothing but 27 degree. Clear? So 1, 2, 3, 1 plus 27. That means 1, 1, 5, 8. Okay, 1, 2, 5, 8. Okay. So answer will be what? Answer will be option number. Answer will be option number D. Clear? That will be your answer for this question. Okay. So the same type of sums. Okay. Here the room temperature T1 is 27, R1 is 65. Clear? T2 we don't know. Clear? And R2 voltage by current. Only this part is different from the previous sum. Okay. So 220 by 2.8. So this. Now the formula R2 is equal to R1 into 1 plus alpha into T2 minus T1. So from this we have to find out the value of T2. Clear? All the values are known. Clear? Now we have to find the value of T2. Only the calculation from here. Okay. So it is coming 1258. Clear? 1258 degree centigrade. So option number D is correct. So students, hope you have understood this. Clear? The option number D is correct. Okay. So this sum is also very important for the entrance examination or NEET examination. Clear? So now let us move to the question number 13. Okay students, now let us move to the question number 13 of today's episode. Clear? So our the same type of sums, the wire has a resistance of 2.5 ohm at 28 degree centigrade. Here room temperature is not given, the temperature is given 28 degree centigrade and the resistance of 2.9 ohm at 100 degree centigrade. Clear? So the two temperatures are given and the two resistance say that two different temperatures are also given. That means R1, R2, clear, and the temperature T1 and T2 are given. Now alpha, temperature coefficient of the resistance, that we have to find out. So it's very easy. Clear? So the four options are given. A is equal to 1.06 10 to the power minus 3 degree per coulomb, B is equal to 3.5 into 10 to the minus 2 degree per coulomb, C is equal to 2.22 into 10 to the minus 3 degree per coulomb, and D is equal to 3.95 into 10 to the minus 2 degree per coulomb. So now here what is given? R1. R1 is given, the temperature at 28 degrees, the resistance at 28 degrees centigrade. Clear? Is 2.5 given. T2 28 degree initial temperature, R2 is the final resistance. Clear? As the temperature T2 is equal to 100 degree centigrade. Now the simple formula R2 is equal to R1 into 1 plus alpha into T2 minus T1. Okay, the temperature difference or increase in temperature, alpha means what? Nothing but the temperature coefficient of the materials. Okay, of resistance. So temperature coefficient of resistance of the materials. Okay, so what is the value of R2? We are only putting the value. So R2 is equal to 2.9 is equal to, what is the value of R2? 2.1 into 1 plus alpha into T2 minus T1. T2 means what? 100 final temperature and initial temperature T1. So T2 100 minus 28. So from here, okay, 2.9 divided by 25. Okay, this one will be shifted that side, left hand side. So minus 1 is equal to alpha into 100 minus 28 means what? 72. Clear? So alpha is equal to 1 by 72 into 2.5 will be the LCM. So 2.9 minus 2.5. Okay. So is equal to 1 by 72 into, it is what? 0.4 by 2.5. So this is coming 2.22 into 10 to the minus 3. 2.22 into 10 to the minus 3 degree per coulomb. Clear? So option number third. So the answer will be option number C. Okay. That will be the answer. Okay, of this question. So very easy. So the two temperatures are given, 28 degree and 100 degree, and the resistance of the two at these two temperatures are also given. It is what? 2.5 and 2.9 ohm. Clear? We have to find out the temperature. Okay, the temperature coefficient of resistance of the materials. Clear? So very easy. So R1 is given, T1 is given, R2 is given, T2 is given. So the formula R2 is equal to R1 into 1 plus alpha into T2 minus T1. So from this formula we can put the value of R1, R2, T2, T1, and we can find out the value of alpha, which is coming here 2.22 into 10 to the minus 3 degree per coulomb. So hope you have understood this. Clear? So now students, let us move to the question number 14. So students, now let us move to the problem number or the question number 14 of today's episode. Clear? So a heater coil is rated 100 watt 200 volt. It is cut into two identical parts. That means the coil, the heater coil is there. Okay, it is cut into two identical parts. Okay, it is cut into two identical parts. Clear? Now the thing is that and are connected together in parallel. That means they are connected together in parallel. The two identical parts are connected in parallel. Clear? So now what happened? We have to and it is connected to parallel in some source of 200 volt, and also it is connected in parallel and it is connected also with the source of 200 volt. Now energy liberated per second from this combination. Okay, very easy sum. So the resistance of the coil R is equal to what? V square by P. P means the power. Okay, V means the voltage. What is the voltage? 200. Clear? 200 is the volt and W what is the power. So 200 into 200 V square by P. 200 into 200 divided by 100. So 2 zeros are cancelled. So it is 400 ohms. Clear? 400 ohms is the resistance of the coil. Clear? Now it is cut it in the half part. That means each part the resistance will be what? 200. Clear? So the resistance of each part is each half is what? 200. The resistance of each half will be what? 200. It is it is identical. Clear? And it is cut into the two equal halves. That means what? The resistance of each half will be what? 200. Clear? Now equivalent is as they are connected in parallel. So if the two resistances are connected in parallel, the equivalent resistance. So if the two resistors R1 and R2 is there, so equivalent resistance R is equal to what? R1 into R2 divided by R1 plus R2. That is the equivalent resistance. So we are using the formula. If two resistances are connected in parallel, then equivalent resistance will be what? Product divided by their summation, their sum. Clear? So the product means 200 into 200 by 200 plus 200. As the two resistances are same value, are of same value, 200 each. So 200 into 200 divided by 200 plus 200. So it will be what? 40000, 4 number of zeros are there, and it is 400. Okay, so it is 40,000 by 400. So after doing the calculation, it is coming what? 100 ohms, or it is R dash. Clear? Now energy liberated, it is what? V square by R dash. Okay, so the energy liberated per second will be V square by R dash is equal to V means what? It is connected in 200 source. Clear? 200 volt voltage source. So 200 into 200 divided by R dash means the equivalent resistance is of the two resistor of each 200 ohms. Clear? So the equivalent resistance is 100. Clear? So the 200 into 200, 200 means the voltage of the main. 200 into 200, V square means 200 into 200 divided by R dash means what? The 100. Okay, then what is coming? 400 joule. So which is option correct? Option D. So the answer will be option D. Clear? So I am now explaining once again. Clear? Now the heater coil is there. Okay, and it is rated 100 watt. Okay, and 200 volt. Clear? Now it is cut into two identical parts. Both parts are connected together in parallel in some source of 200 volt. The energy liberated per second, okay, of the combination is 4 options are given: 100, 200, 300 or 400 joule. Clear? The resistance of the coil R is equal to what? V square by P. Okay, P means power. Clear? So V means 200 and power means 100. Clear? So that means 200 into 200 by 100. So it is 400 ohms. Now this is now this coil is cut into two equal halves. Okay. So the resistance of the each half will be what? 400 by 2, that means 200. Clear? Now the equivalent resistance, those are connected in parallel. So equivalent resistance will be 200 into 200 divided by 200 plus 200. Okay. So it will be 40,000 by 400 is equal to 100 ohms. Okay. It is R dash. Okay. So energy liberated per second is equal to V square by R dash is equal to what is the value of V? It is connected with the 200 volt main. So 200 into 200 divided by R dash means the equivalent resistance of the two resistances, that is 100. So it is 400 joule. Clear? So option D is correct. Okay. So students, hope you have understood this very easy sum. Clear? Only you have to use the formula in a right way. Clear? So hope you have understood this. Now let us move to the next problem number 15 and the last problem of today's episode. Okay. So let us move. Okay students, so now let us come to the problem number 15. Clear? So what is that? In a circuit shown in the figure, okay, so what we have seen, that 2 ohms and 4 ohms are connected in parallel and 3 ohms are there connected in series with them. Clear? And the current flow entering to the circuit is I. Okay, suppose so this is will be I1 and this will be what? I2. Clear? And these two will mixed over here, and the main current again it will be I through the 3 ohm resistor. Okay. Now the heat generated, okay, the heat developed in the 2 ohms, 4 ohms and the 3 ohm resistances R will be in ratio of 2:4:3, option number 1. It will be 8:4:12, astronaut 3 4:8:27, and D will be 4:8:4:27. Clear? So the three options are there. Okay. So how to do this sum? It's very easy. Okay. So first we have to calculate the current I1 through this 2 ohm resistor. Okay. So students, if you have seen the galvanometer and shunt flow, okay, so from that formula, galvanometer shunt formula we have to use, because suppose we can assume as galvanometer, this we can assume as shunt. Okay, two resistances are connected in parallel. So current through the 2 ohm resistor I1 is equal to what? This, okay, resistance of this divided by the sum of the two resistances into the main current I. Clear? That is the galvanometer. Suppose IG how can write? Okay, S by S plus G into I. Clear? So that this is the formula. Clear? So here this is what the current through this resistor. Okay, what we can, how we can write? The current through this 4 divided by 2, the sum of these 2, 4 plus 2 into the main I. Okay, so it will be what? So 4 by 6. So if we cancel it, so it will be 2I by 3. Clear? So the heat produced H1 is equal to what? I square into R. Clear? The heat produced. Okay, so I means, so I1 means what? 2I by 3. So 2I by 3 whole square into R means what? 2. Okay, that means what? It will be 4 into 2 means 8. 8I square by 3. Clear? Sorry, it will be 8I square by 9. Clear? 8I square by 9. Now the current through the 4 ohm resistor. Okay, so what will be there? 2 divided by 2 plus 4. Okay, into the main current I. Clear? So the current through 4 ohm resistor will be what? 2 this resistor divided by the sum of the 2 resistor into I. So it will be 2I by 6. It is equal to I by 3 into I. Okay. So heat produced H2 is equal to I2 square into 4. So what is the value of I2? I by 3 whole square into 4. So 4I square by 9. So the main current I now here, the current through the 3 ohm resistor will be the what I only. Clear? Because this 2 I1 I2 will be attached over here and it is I. Clear? So the heat is equal to I square into R. So 3I square. So we are multiplying both the numerator by 9. So it will be 27 I square by 9. Clear? So the same thing, why you have taken here 9? Because the denominator of all the other two H1 and H2 are 9. Okay. So H1 is to H2 is to H3 is equal to what is H1? 8I square by 9 is to what is H2? 4I square by 9, and what is H3? 27I square by 9. So 9 will be cancelled. So it will be what? And I square will be cancelled. 8 is to 4 is to 27. So option number D will be correct. Clear? So the answer will be what? Option number D. Okay. So I am explaining it once again. What is given? The two resistors are connected in parallel and one is with series. Okay. So current through this will be what? The 4 divided by 2 plus 4 into I. Okay. So 2I by 3. Current through 4 will be what? 2 divided by 2 plus 4 into I. Clear? So that means what? I by 3. Clear? Now the heat what? I square into 2. What? The heat through produced in 2 ohm resistor. Similarly, the heat produced in 4 ohm resistor, it is I2 square into 4. Clear? So I2 is what? I by 3. So I by 3 whole square into 4. 4 I square by 9. Now the current through the 3 ohm resistor, this resistor is what? I. Clear? So 3I square is equal to 27I square by 9. We are multiplying both numerator and denominator by 9. Clear? Now the H1 is to H2 is to H3. 8I square by 9 is to 4I square by 9 to 27I square by 9 is equal to 8 is to 4 is to 27. So students, hope you have understood the today's episode. Clear? So I will upload. I am giving you my words that I upload more than 200 MCQ on this chapter chapter current electricity. Clear? And each chapter I will try to cover. Okay. And if you practice all the MCQ repeated times, then I hope you can crack the NEET and joint entrance exams. Okay. And it will be easier for you. Okay. So hope you enjoyed this episode. So I will upload the next episode very soon. Keep watching. Thank you.